Okay, welcome to vertical and adjacent angles. So at the top, the notes say that angles are formed when two lines intersect. I'm going to get my laser pointer tool out here, and you can see that we have line Y right here. That's this side. And then line X right here. And so since these are intersecting, it forms four different angles. So we have angle A, angle B, angle C, and angle D. Then it says, in the picture below, lines X and Y are straight lines that intersect. Use a protractor to measure each of the four angles that were formed and complete the table. So if you're doing this as a student that was absent, I want you to please grab a protractor and measure all four angles. Pause the video and do that, please. Okay, so hopefully you've done that. And what you found is that angle A is 55 degrees. And then angle B is 125 degrees. And then angle D is also 125 degrees. And then angle C is also 55 degrees. And then you're going to take all that information and you're going to fill it in on this side here. So angle A is 55 degrees. And angle C is 55 degrees. Angle B is 125 degrees. And so is angle D, 125 degrees. So then when it says, what do you notice about the angle measures? I want to make sure that you are noticing that angle A and angle C are congruent, which means they're the same measure. So what you're going to say is angle A, and this is the symbol for congruent, is congruent to angle C. And we also know that angle B is congruent to angle D, okay? And we can see that in the diagram. There's a couple other things that we could notice here. If you look here, anytime these two are connected, so these lines here, they form a straight line. So 55 plus 125 do make 180, and so that's important to notice as well. So if this is 180, and then we add this other thing right here is also 180, or if we just add all these together, go ahead, pause the video, and add all four of these together. You should get 360 degrees, which makes sense because this is like a complete circle. Turning all the way around gives us 360 degrees, or half of that is 180. Okay, so now that we've actually seen this in action, we can define what these are. So notice that the angles that were opposite each other are the same. That's called a vertical angle. So all those times in that thing up above where they are intersecting, or where they're opposite and they're the exact same, that's called a vertical angle. So some examples of this is up above, A and C were congruent. And then we also had B and D were congruent. They were the exact same in intersecting lines. The opposites are the exact same. So B and D, and we can put that these are congruent. I'm going to put the symbol for congruency. Okay, the next item we have to talk about is adjacent angles. So adjacent angles are two angles that share a common side and a common vertex. So basically what this means is that angles are touching, right? So up above, we have angles A and B that are touching, okay, because they share a common side and they share a common vertex, the vertex being the exact center where they intersect. So angle A and B were angles that were touching each other. They're called adjacent angles, okay? And then we have the other side of that. So B and C are adjacent. There's other examples too. D and C are also adjacent. There's a lot of examples of angles which are touching each other. It's just in a situation where two lines are touching, or two lines are intersecting, these lines are intersecting, okay? Okay, and now remember that those two angles formed a straight line, which made so they added up to 180 degrees. So you can put that under the relationship that they add to 180 degrees, but we have a word for that. So since we have a word for that called supplementary, I'm going to type that in here. They are supplementary. Okay? We have a word for what, these things combining to make 180 degrees. And while we're at it, I'm going to add the word congruent with that symbol that I wrote. So let's put that in your notes as well. And I'm going to put that up here, okay? So that we know and we remember that the symbol means that they're congruent, okay? There isn't really a symbol for supplementary, so we're just going to leave it like that. All right. Now in this next section, we're going to actually apply what we know. So if we look at question number 1, see how this side right here is 148 degrees? We know that the opposite side is also going to be 148 degrees. So we know that this is 148 degrees for angle X. All right, so angle X is 148 degrees. And angle pair, what that means is like, what's the relationship? So if we look right here, there are 2 types of angle pairs that we've learned so far, vertical angles and adjacent angles. So what are these 2? These are the kind where they're opposite, and opposite meaning that they're congruent in this relationship here. So vertical angles are congruent. So we're going to put vertical angles here, and I'm okay with you guys just abbreviating and saying VA for vertical angles, okay? Now, if we go over here, this angle on on question 2 is 35 degrees, and then we have this X value. Okay, now remember, these 2 are touching in a situation like this where we have 2 intersecting lines. That means the 2 that are touching are going to form a straight line, which is right here. And if they form a straight line, we know that these are supplementary. So I'm going to write right here, first of all, that these are adjacent angles. Okay, and put that up. They're touching in a situation like this where we have intersecting lines. And anything that's adjacent, if we look here, it says that the relationship is that they are supplementary, which means that they add to make 180 degrees. And we know that because they form a straight line. So what you're going to do is X plus 35 is 100 degrees and solve to find out what X is going to be. So we're going to take 180 because that's what they're going to combine to make. So take 180, you can do this in your calculator or you can do it in your head, and subtract 35. Okay, here's how I do it in my head. 180 minus 30 would give me 150, minus 5 more would give me 145. You can do it in your calculator or you can do it in your head the way I just did. That is 145 degrees. So we're using what we know about these 2 relationships, vertical angles and adjacent angles, to solve for missing angles in a diagram. Okay, now this page should go pretty fast for you if you know vertical and adjacent angles. So right here it's telling us that angle 2 right here is 45 degrees. Well, we know because of adjacent angles that the opposite angle is going to have to be the exact same. So angle 2 and angle 4 are the same, which means angle 4 is also 45 degrees. Okay, and now we know that these 2 are going to be the same. So if we find 3, then we also know what number 1 is as well. So what we have to do now is use what we know about adjacent angles. So these 2 are touching, right? Which means that these 2 are supplementary. So 2 and 1 are supplementary. If 2 is 45 degrees, then you need to figure out 45 plus what, right? Plus what for this side right here is going to give you 180 degrees. So the way that we can figure that out is we can do 180 minus 45. So what we know it's going to add up to minus what we already have, minus 45 degrees. Okay. And I know that 180 minus 40 would give me 140, minus 5 more is 135 degrees. And you can do that on a calculator if you prefer. So that means this needs to be 135 degrees because 45 plus 135 equals 180. So then we know that angle 1 is 135 degrees. And because of adjacent angles, vertical angles, the opposite side is going to be the exact same. So 135 for this side as well. And that is how you solve a question like this. Now we know every single angle measure in this figure. And I'm going to let you guys do the rest of this on your own. I think this page will be done pretty quickly for you. Okay, now this page is kind of turned up on the spice a little bit more. So what I mean by that is it's just a little more spicy than the other page, but you'll be just fine. So here we go. Now, these 2 angles, what it's saying here is that this angle, 94, plus this angle, which is x, we don't know it. When you combine them, when you add them, you get 117. So it's kind of like a vertical angle, or I'm sorry, not a vertical angle. It's kind of like a supplementary angle or a complementary angle. Well, instead of 90 and 100, now you're saying it's equal to 117. So the equation that you can make is you can say, well, if I took the 94, which is the first angle I'm given, and if I add x to that, so plus x, if we put these two together, it's going to make 117 degrees. So that's the equation that you're going to start out with, 117. Okay, now to solve this, we know that we can just draw a straight line down the equal sign. We want x to stay by itself, so we have to get rid of the 94. It says that they're being added together, so the way to get rid of the 94 is to simply subtract the 94 to the other side. Okay? And then I like to kind of draw a line as kind of a review of equations. Drawing a line, that gets rid of my 94, so that's gone. And now I have x equals, and then you're going to get a calculator or do in your head 117 minus 94, which is 23. So I'm going to put that right here as well. The value of x is 23. Then when it says the measure of the two angles, so in this one, x is simply the angle. So you can just say that this angle right here is 23. And we already know that the other one is 94. So this one, the first one we were given, is 94 degrees. I'm going to put a degree symbol up here too. 94 degrees, and then the x is 23 degrees. So x was simply the other angle. Whereas in this one, in the next one, x is going to be this angle is going to be 2x. So whatever x is, you'd have to multiply it by 2 to figure out what that angle is going to be. We're going to do that one in just a second. Just a quick heads up. Okay. All right. So that's this first one. Okay. Now let's go to this next one. So what this is saying, very similar, only now we have x instead of a constant and an x. So 2x plus x equals 141. So what we're saying is if we took these two angles, 2x and x, and we add them together, we put them together, it would make this angle, which is 141. So I'm going to write that as an equation. 2x plus x equals 141. Okay, now this can be simplified because I can put 2x and x together. These are like terms. 2x plus x is 3x. So it says 3x equals 141. Now, we have to use our algebra skills. This says 3 times x. So the way to get rid of that 3 is to divide by 3. That gets rid of the 3, and we get x equals whatever 141 divided by 3 is. I'm going to clean this up just a little bit, just so that it looks a little bit nicer. We are dividing 141 by 3. Which gives me 47. So I'm going to put right here, when it says what is the value of x, it is 47. Now, this is what I'm talking about with the measures of the angles. X might be 47, but you have to look at the diagram to see that x was referring to this angle right here. So this one is 47. And then we have to look at the other angle, which says it's 2x. So this angle here is 2 times, and we replace x with 47. So this one is not simply 47, this one is 2 times 47. And we can do this piece on your calculator, or you can do it in your head. 2 times 40 would give me 80. 2 times 7 is 14, so 80 plus 14 is 94. So this one's going to be 94. Oops. The first angle here, the big one, is 94 degrees. And the other one is 47. So then what I would do, too, to make sure that this works, is I would do, in my calculator, 94 plus 47, and check to make sure that that actually does give me 141. And if it does, I know I did this right. Okay, next up, because we understand vertical angles, we know that this angle is going to be equal to this angle. So when I set up the equation, I'm just going to go, okay, 3x is going to equal 20. Okay, and then just like in the other example, if I draw this line, this means 3 times x, so the way to get rid of it is to divide by 3. And then I have x equals 20 divided by 3 is going to give me a repeating decimal. So because that's the case, I mean, you can do two different things. You can just use the repeating decimal, which is 6.6 repeating. You could just write that down. In fact, I'm going to start it that way, 6.6 repeating. But then for the sake of the value of x, you could also just put this as 6 2/3. So either way, if you leave it as a fraction or if you write it like this, I'm even okay if you write it as 20 divided by 30 on this value, or on this line right here. That's fine, but I'm just going to leave it like this. This is the value of x, okay? Now, angle measures. We know that the first one right here, the one we were given, is 20. So I'm just going to write that one down because we already know that that one's 20. Now, for this one, though, we have to do 3 times x, because x is not simply the angle. The angle is a little bit more complicated than just x. It's 3x. So we have to do 3 times 6 2/3, or 3 times 6.6 repeating. And then we're going to plug that into the calculator. This is 6 2/3 times 3. And if you do that, you'll realize that that is 20. The nice thing about this, though, too, is that I took you through it the long way first. But remember how we said these are going to be equal? Well, then that means that this one's also 20. So you can do that, or you can just say, well, I know that they're going to be equal, so they're both going to be 20. There you go. Okay, on the next section, angle relationships allow us to determine any unknown angle measure. All angles around a point or vertex will always have a sum of 360 degrees. So what that means is if we're looking at this figure right here on 6, this is the point or the vertex that all these angles are sharing. And what we just read tells us that if we added all these things together, so we add 60 plus 40 plus this angle K plus angle M plus angle P, if we add all these together, it would make 360 degrees because it's going all the way around. So that's a relationship that we have in our tool belt that we can use. We can also use adjacent angles, things that add up to 180, or we can use vertical angles or any of the angles that we've been taught. We can put them in our tool belt and find the appropriate angles, or the angles that they're asking us to find. So because the first thing that they're asking me to do is to find angle K, what I'm going to do is look for a relationship that's useful to me. I know already 60 and 40, and if I continue this little arc all the way with K, I can see a clear relationship between 40, 60, and K. And that is that they form this straight line right here. And what do we know about when things form a straight line? We know that they make 180 degrees when we put them together. So then I'm going to go ahead and say, okay, here's an equation then. If I take 60 and I add 40 and I add K, if I add all these angles together, I get 180. Then I can solve this. Well, I know that 60 plus 40 is 100, so K has to be 80 to make this equal 100. We can also just take 180 and subtract 60 and then subtract 40, and we get that K is 80. So I'm going to put that right here. K, I know, is 80 degrees. Okay, now they're asking me to find angle M. So I look for a relationship that could be useful to me. There's a few things I could do. I could find a vertical angle with angle M, and I could see that that is this angle here. So I could put that M is 60 plus 40. If I also know that K is 80, then I know that M and K make a straight line, so this has to be 180 plus this equals 180. So that's something that we can do as well. I'm going to do this one. I'm going to do the vertical angles option. So I know that M is a vertical angle with these two together, so these two would have to be congruent. That means that M would have to equal 60 plus 840. Those two angles together. And 60 plus 40 is 100. So I'm going to say, okay, great. That means the measure of angle M is 100 degrees. And that makes sense because then if I put these two together, 100 plus 80 would be 180, so we don't have any contradictions there, and everything seems to be working out. The math is mathing, as my kids like to say. Okay, this next one here, I'm going to set up, and then I'm going to have you guys complete. So this is asking me to find angle G. So if I'm looking at angle G, let's identify it here. I need a relationship that's going to help me with angle G. Now, I could try to use vertical angles, but if we look at the vertical angle with G, we don't know what this is. So that's not going to help me much. So I'm going to look at another thing I could use. Well, this makes 180 degrees if I put all these three together, because this makes a straight line right here. So what I can say then is that 32 degrees, that angle right there, plus, now remember this symbol right here means that that's 90. So plus 90 equals 180 if I put those together. So I'm going to use that fact right there and find angle G. So I'm going to leave you to that to solve this equation and find angle G. Oops, and then I just realized that I made a quick mistake in here. This needs to also include angle G. I'm going to write that better. All right, that's better. The angle 32, right? Here's where the 32 comes from. 32 plus the 90 plus angle G equals 180 degrees. And we need to solve that equation to figure out what this one is. Okay, now the next thing after you do that is you are tasked with finding angle J. That's what this says right here, find angle J. Well, angle J is right here. So if I knew what G was, I could easily find J, because if you notice, these two make a straight line right here. So J plus G equals 180 degrees. So that's what I would set up as my equation. Whatever you find for angle G should go here. Angle G plus angle J. Remember, we don't know what that is yet. So if we put these two things together, they equal 180 degrees. Okay? And then if you solve that, you'll be able to find angle J. Okay, similarly on number 8, if I add all these three together, I know that they would make 180 because they make this straight line. So my equation is going to be 29 plus Z plus 112 equals 180. So I'm going to set that up right now. Okay, my equation is going to be 29 plus whatever angle Z is, we don't know what that is yet, plus 112 degrees is going to equal 180. I'm going to move that down here. And then to solve it, we would just take 180 and subtract 112 and 29, and that will give us what angle Z is. I'm going to leave this for you to do as well, because I want you to be able to do them. Okay? All right. Next up. Okay, so then at the bottom it says summarize today's lesson. So in this lesson, we covered using vertical and adjacent angles to find missing angles. Okay, and then you can also say, instead of vertical and adjacent angles, you can say using angle relationships to find missing angles. That's also an appropriate answer as well. But I do want you to put something down there where you are summarizing the lesson.